introduce Professor Pallavi Lakshmikant Rahinj, who is presently serving as head of the Department of Computer Engineering at Rajiv Gandhi College of Engineering, Karzule, Haria, Ahilyanagar. Professor Rahinj has over 15 years of teaching experience and been leading her department with dedication for past decade. She holds BE in Information Technology and MTech in Computer Science and Engineering and is currently pursuing her PhD in Artificial Intelligence from Nirvan University, Jaipur. Her area of specialization include computer networks, artificial intelligence, machine learning, deep learning, data structures, computer graphics, discrete mathematics. She has published more than 15 research papers in reputed national and international journals and conferences and continues to contribute actively to academic research and innovation. Today, she will cover unit number 5 on computer network syllabus. So please let's all welcome Professor Pallavi Lakshman Rahinj. Ma'am, is your audio on?
Yes, ma'am. Yes, ma'am.
Yeah, thank you. Welcome, ma'am. Hand over to you, session.
Okay, thank you, Shruti, ma'am. Okay, my screen is visible.
Yes, ma'am. Your screen is visible.
Yes. Wait just a minute.
Yeah. Now it's clearly visible, ma'am.
Okay, good morning,
Yes.
everyone. Today, first session is covered by Dr. Lahani sir on unit 1 and 2. Here, due to some reasons, unit 3 and 4 is not covered directly. I am covering the unit number 5 that is based on the application layer. Okay, so Lani sir already covered the what is the teaching scheme. We required the theory 3 hours, right? And CC having 30 marks and semester 70 marks theory. Here directly I am switching on my course objective. Here is having for computer networks 5 course objective. I am going to focus on fifth one, course outcomes. Okay, here is a 5 COs. So last one is a demonstrate understanding of application layer protocols and apply that application layer protocols in a network applications. Okay, so see, this one is the points for the unit 5, introduction, principle of application layer, client server and peer-to-peer model, then web, HTTP request and response, then persistent versus non-persistent connections, cookies, caching, performance, then resource records, name resolutions, catching, security issues, email, in that covering the some protocols, SMTP, MIME, POP3, IMAP, webmail, message format, security. Then next one is a FTP, in that covering the basics of FTP, file transfer process, legacy privileges. Then Telnet, it is used for remote logging, also covered its limitation and legacy use. The next one is a DSCP dynamic host configuration protocols. In that main point is a IP allocations, then management. Then next one is a SNMP protocol, which is used for network management, monitoring. In this covered the some topics, MIBs, security considerations, emerging topics like the multimedia applications, then RTP protocols for streaming, peer-to-peer application, cloud-based services. And included here in a fifth one unit, some case studies based on DNS security attacks, that is the DNS snooping, and then HTTP catching in CDNs and SMTP in enterprise email system. So let's start the unit overview. That is the application layer is the topmost layer in the TCP IP stack. It defines the protocols that let network applications like the browsers, email, clients, file transfer tools, exchange the data using services provided by the transport layer. In mainly transport layer, we study TCP and UDP protocol for transferring. Okay. So here is a giving the 9 hours for this covering this application layer unit. So it is the most important layer in a stack to directly use this whatever the protocol present in an application layer directly used to give the services to the clients. So I am focusing on CO5 demonstrating understanding of application layer protocols in a network application. So finally in this we got the learning objective. By the end of this unit, students will be able to first one explain the what is meant by client server and peer-to-peer architecture. Then most important point is the HTTP request and response. Then what is the DNS hierarchy, its resolution and security threads. Then next one is a comparison between SMTP, pop-up tree, IMAP for email delivery and uses of FTP, Telnet, DSCP, SNMP like this. And out of these protocols, some protocols are involved in a practical sessions for how it works, how it configure. Okay, it will be the covered in a practical session. Next one is a what is actually the application layer. It is the topmost application layer. Here is a stack. First one having physical layer, then data link, network, then transport, and it contains the uh, at the top application layer, which includes their protocols, that is the SPPP, DNS, SMTP, FTP, DSCP, and SNMP. So mostly focus on while studying to the students which application layers consist of which protocols and their port numbers. That is the main focus while studying to the students. So in that, having the different roles of particular protocols that also explained to the student. Then main two architecture, client server, that is already explained by the Dr. Lahane sir. The next one is a peer-to-peer architecture and having hybrid of both. In a process communications, we use the sockets which is covered in a transport layer. Okay. Then next one is addressing, which is used by using TNS system in the having IP address plus port numbers. For example, HTTP is a protocol which is having the 80 is a port number, DNS is having the 53 port number. Like this, student remember always the which is the protocol for which layer and having the which port number. Okay. The next one is a client server architecture. So client is sending the request to the server and server gives the response to the client. So here is a client means the basically browser or any application, and server is always on and having the fixed IP. Basic these things we need to study to the students. Okay. Then how advantages of this one, client server architecture. Actually in a client server architecture it is the centralized control. Okay. A server is having all data and all backup consist on a single server. Then but there is having disadvantages. It is the single point of failure. Whenever the server can become bottleneck, then all working is going to stop. So this is the disadvantage. Example of client server architecture is a web browsing, email, and file download. For this particular web browsing, student must understand which protocol is used. STPP for email, SMTP protocol is used for the file downloading. FTP protocol is used. So next one is a peer-to-peer model. Peer-to-peer model is a different. Here is a comparison table. Actually, control in a client server is a centralized, means having one server. But in peer-to-peer, here is a diagram having the different servers, means peer 1, peer 2, peer 3, peer 4, and peer 5. So in that, we get the benefits of scalability and reliability. So what is meant by reliability? Actually, in client server, if a single point is failure, then nothing happened while the working. You didn't get the connection to the clients or didn't get the service to the client. But in peer to peer, there is a, if one point is get failure, then also second one point gives the service to the clients. Means it is just not available. It is continuously gives the service to the client. That is known as a reliability. Okay. Then point of view of cost, client server model requires the higher cost because server infra, but in peer to peer required the low cost because having the resource sharing, so cost get minimized. So example of client server is web and email, but example of peer to peer is a BitTorrent. You always downloading the whenever, for example, downloading the Linux operating system on a BitTorrent, we get the very fast speed for downloading the BitTorrent. Why? Because we uses the different server and it gives the that particular file in a partition. So we get the lots of speeds to downloading that particular software. Okay. So next one is a web and HTTP. This topic is known to the very well how the HTTP protocol is used for accessing the web. It is having the request response model. Having the web browser is the HTTP client. We use the method get to send the request. Web server, for example, is Apache. So it gives the service to the HTTP client. Okay. In that content is right in a HTML pages. So it is the actually stateless. Server does not retain any memory of the past request by default. Means it not save the history, right? So for that, we use the cache. We will cover in a next slide that point. Okay. So in this having request format is request line plus header plus optional body, and for running this HTTP over the TCP, use the port 80 or 443. This should be the get understand to the students. Next one is a HTTP connections, persistent versus non-persistent. What is the exactly difference between the persistent and non-persistent? So in persistence, having only one connection to the many objects, and in non-persistence, having the new connection per object. And which type of connection? TCP connections. Okay. So in persistent, overhead is the low because having one connection to the many objects, right? But in non-persistent, having overload is high. This difference is important. Exam point of view, student must differentiate between what is the persistent connection and non-persistent connections. Here is a calculation of RTT per object is also important, but is difficult to the student for calculation. So we just study the three handshake lemma first, and then try to explain the RTT. The next one is a cookies caching and web performance. In that, cookies is a small data set by the server stored in a browser, return on a subsequent request to maintain the state. because in HTTP is a stateless, which is not store the history, right? So we here use the cookies. How to use these cookies? By session and login management, in a shopping carts, personalization or tracking. In a cookies, having the flow like the server sent the set cookie header, then browser stores it, then browser resend the cookies header on future request, and privacy concern third party cookies enables the cross site tracking, like that. Then what is the web caching? It is also known as a proxy server which stores the copies of recently requested objects. Then benefits. What are the benefits of this? Reduce the response times because we get immediately the whatever the pages or objects we require. Also, it reduces the traffic on the access link and reduce the load on a origin server. The next one is a cache validation. It is the conditional get if modified since header avoids the re-downloading unchanged content. And in this also cover the performance matrices. First one is a latency, then throughput, then effective bandwidth improves the significantly with the caching and CDNs. A real world example for this one is a cache static contains across the global edge servers, cutting latency from 100 seconds of milliseconds to single digit milliseconds for popular content. Then mostly important topic is a DNS server, hierarchical namespace. Okay. Sorry, in that having the DNS is a domain name system, which is the shown by the hierarchically. Why it is shown by the hierarchically? For remembering actually, because whenever you providing the IP addresses directly for use, it is very difficult to remember to the human being that number system. So we provided the some specific name to show that DNS systems. Like for example, is a google.com. Whenever we router needs the IP address like this 142.250.193.46, it is too much difficult to remember. So we use the domain name is a google.com. So here is a having the hierarchical structure. First one is a root DNS. Then whatever the your domains .com, .org, .education, .in, like this. So in this having top level domains like this. It is also the distributed and scalable. Now the single server holds all mappings and avoids the single point of failure and traffic bottleneck. This is the advantages of DNS system. Exam point of view, main topic is a DNS resource records, how it stores the records. So here is having some types of record types, A, then 4 times A, CNAME, MX, NX. What is the purpose of these record types? For A, it is maps the host name to the IPv4 address. For example, www.site.com, which is having the this one IP address. Okay. Then next one is a for example MX is a mail exchange server for domain, right? So in that having site.com, we write the mail.site.com. They also in this cover the name resolutions, recursive query which is sent by the client to the local DNS server. The server does all the work combined with iterative queries like the local DNS server sent to the root, then TLD and then authoritative. In a DNS system having some security issues, that is the DNS spoofing. In that, attackers eject the forged DNS response, mapping a legitimate domain to a malicious IP. In this mechanism, exploits the weak transaction ID Also having the source port randomization or intercept the unencrypted UDP query and responses. So what is the impact of that? Victims are silently redirected to phishing sites, malware servers, or man in the middle proxies. So in that, having other DNS threats are DOS attack on DNS infrastructure, DNS tunneling, that is the data exploitation, domain hijacking, like that. It is used in a defenses, then DNS over the HTTPs, TLS encrypted queries, regular cache flushing. And a real incident reference is a large scale spoofing attacks, that is the against banking in a social media domains. They steal our personal information or private information from the banking. So, have redirected millions of users to the fake login pages to harvest the credentials. So, next one is a common topic is a email. For that, student basically knows the which protocol is used for transferring the email information. That is the SMTP, which is the simple mail transfer protocol, which push the protocol used to send and relay the mail between mail servers, which is run over the TCP port 25. This number is important to remember to the students. So how it works? Users agents hands the mail to the senders mail server, then SMTP relays it possibly via multiple hoops, then receivers mail server. Okay, so here is a it transfers only the 7-bit ASCII text. So for email architecture, we use the SMTP along with the MIME protocol, which is known as a multipurpose internet mail extensions, which extends the emails to carry the non-ASCII data also, means images, audio, then videos, attachments by encoding them in a base 64 bits with headers like content types. So for transferring these emails, having some commands, that commands is required to remember the students, that is the HELO, then mail from RCPT, TO, data, quite like this. For mail accessing, we also use the pop-up 3, then IMAP and web-based. According to the student point of view and exam point of view, we require the differentiation between these three protocols. So pop-up 3 uses the port number 110, then IMMP uses the 143 port number, and webmail which uses the STP protocol, so it uses the 80 port number. Regarding to the storage, pop-up 3 is a downloads and delete from the servers, IMMP mail stage on the server, and for webmail mail stage on also server. So folder supports for pop-up 3 is limited, then IMMP is a full folder support, and webmail also. So for offline accesses, pop-up 3 having offline access, but in a webmail having limited access, it needs the connectivity. A typical uses of pop-up 3 is legacy single device setup. IMP uses for modern multiple device email, that is the Gmail and in Outlook, and webmail is used in a gmail.com for access from any browser. Email message format and security. All of you are very well aware about these things. Email format having from, to, subject, and date, all these things, right? So in header fields having these contents, then in body having actual content, envelope versus header, in that it contains the SMTP envelope mail from RCTP to control actual delivery, header from to it just display the text and can be the spoof. Okay, the in this having the security issues also. So spoofing risk, basically SMTP does not authenticate the senders and enable the forgive prompts. Okay, then SPF sender policy framework, which is used for verifies the sending server is authentic is authorized for that domain. The next one is a DKIM, that is the domain is identify mail, which is used for digital signature verifies message integrity. Then DMARC, that is the policy layer combining SPF plus DKIM result to decide accept, reject, and quarantine. Then TLS, which is used for encrypt the SMTP transmission between mail servers. The next one protocol is a most commonly used for file transferring, that is the file transfer protocol, which is the application layer protocol. So it having the two connection, control connections, which is run on port 21, and second one is a data connection, which is run on a port 20. So here is a having the FTP client and FTP server, right? So in this having the active mode and passive mode. In active mode, server initiate data connection back to the client, and in passive mode, client initiate port the connections firewall friendly. In FTP uses the commands are user pass, list, RETR, download, and upload and coin. Regarding the authentications, we require the username and password while transferring the files. Okay. Regarding security norm, plain FTP send the credentials and data unencrypted, but in FTPS, TL base should be the use in the production. Telnet. Next one is protocol for the remote logging, which is run on a port 23. How it works? In this, client set the keystrokes to the remote host. Remote host executes the commands and then returns the output characters by character. What are the limitations of these telnets? All data, including username and password, sends in a plain text. So it is the vulnerable to the hijacking. So in this, nothing the encryption or storing the authentication building. So having legacy use still used for quick diagnostic connection to test if a TCP port is open. For example, telnet host 80, but SSH, that is the secure cell, which is run on port 22, has replaced it for actual remote administrations. Next one, most important point is a DSCP dynamic host configuration protocols. Actually, how configure these protocols? It is covered in practical sessions. I just give here is the theory. What is the DSCP client? That is the host, and DSCP server, which is having the different requests, that is the DSCP discover, DSCP offer, DSCP request, and DSCP pack. This is the request sent from the client and response sent from the DSCP server. And here practical session is covered in an afternoon. They will be shows the how configure that DSCP protocol, which requires the assigning the IP addresses, subnet masking, how calculate that particular subnet masking, then default gateways, DNS server address, like this. Okay. So in this required the IP address management, server maintains a full scope of addresses and tracks the least status to avoid the duplicate assignment. Exam point of view, DSCP uses the actually UDP, means connectionless. Okay. So that's why it is the fast, since a host has no IP, it when it broadcasts the DSCP discover, it cannot be used a connection oriented TCP handshake. So in exam, always this question is asking how to configure the DSP, and according to the practical point of view also, this one is a very important. Advantages of this DSCP configuration is no required the manual configuration, right? So we get the dynamically IP address, and also it is the centralized management. efficient use of limited address space also. So address space does not get waste. Next one is a SMMP protocol, Simple Network Management Protocol. In that, having the manager, agent, and MIB architecture. So, firstly, it is the application layer protocol used to monitor and manage the network devices. What are the network devices? Routers, switches, servers, and printers, which is run over the UDP port 161. SNMP actually contains some components. First one is a manager, second one agents, then MIB. Uh, in that, having manager is a network management station, agents is a software on managed devices, and MIB means management information base, means information is stored in a structured databases of manageable objects. And SNMP having the two basically methods for sending request and getting the response. That is the get method, which reads the value, and set methods we change the value. Also having the get next, that is the we can search the database by walking in a MIB tree, means management information base, where we store the database in a tree structures. The next one is a tag, which is used for agent productively alerts the manager of an event. For example, whenever the link get down, we get the message. Okay, so MIB is each object identify and OID, means whatever the information we stored in a MIB, which is having the one OID, that is the object identifier. For example, interface status, CPU load, bandwidth uses. The next one regarding security consideration, SNMP version 1 and version 2C use the plaintext community strings as a weak authentication. SNMP v3 adds the real authentication and encryption. So let's discuss the emerging topics related to the multimedia applications and RTP protocol. In this, having multimedia applications, streaming the audios, videos on YouTube, Netflix, right? Then video conference like the Zoom and Google Meet, then internet, telephony, voice over the IP. Okay. In that, having some challenges regarding traditional TCP retransmission and ordering adds the delay that is unacceptable for the real-time media. Occasional loss is preferable to the lag. In RTP, actually real-time transport protocol, which is runs over the UDP, right? So adds the timestamps and sequence number, so the receiver can reconstruct the timing and detect the post out of order packets. Then having the next version of RTP control pro. Next one is a RTP control protocol, which is the companion protocol carries the quality of service feedback. In this covers the jitter, packet loss rate used to adapt the streaming quality. Adaptive streaming means modern services which is run over the HTTP and dynamically switch video resolution based on major network conditions. Okay. Then also having the peer-to-peer application, that is the file sharing by using BitTorrents, blockchains, cryptography networks, decentralized storage. Then it provides the advantages like the self-scalability, content distribution capacity grows automatically as more peers join. Then having the hybrid design, in that most practical is a peer-to-peer system, still use the lightweight servers, that is the bootstrap seed nodes for peer discovery. Also having the cloud-based services, for example, SaaS, PaaS, and okay, like that. Then example for the these peer-to-peer applications are the Google Workspaces, Office 365, then Azure hosted web and DNS services, cloud email relays, and spam filtering. Application layers, angles, it covers the cloud services still rely on the same core protocol study. In this unit is a HTTPs, APIs, DNS-based service discovery, SMTP relays, and delivery at the massive elastic scales. So actually, every new internet trends having the peer-to-peer sharing, streaming, cloud apps, is still built on the same application layer foundation, that is the using the client server architecture of peer-to-peer architecture by using the application layer protocols. We cover all this in unit number 5, application layers, and it includes the some case studies which is regarding to the STP sketching and enterprise SMTP. Here is a one slides regarding the what are the protocols existed at application layer, its full form, then its codes number, and what are the purpose of these protocols. Okay, this is the important to the students learn this from this unit number 5 and utilize at the application level. So some are the resources to study the computer networks. Best books are the Tenenbaum, then Forozan, and William Stellings. Also having some reference book, we just included having some authors write the top to bottom approach, or some authors write the stack in a down to top approach. But from bottom to top approach is a best one, because we first study the physical layer, then data link layer, then network layer, then transport layer, then application layer. So easily we student also get understand how the data is transferred from one layer to another, and how deliver it to the clients. Okay, so thank you.
Thank you, ma'am. Thank you so much. Uh, your systematic explanation about exam oriented, about all the approaches, about top down and bottom up approaches, also exam oriented teaching and application oriented methodology about this particular unit. It's a huge unit. Have successfully completed a theoretical coverage of revised computer network syllabus. We sincerely appreciate your valuable guidance. Thank you, ma'am. Thank you so much.
Thank you. Thank you. Is anyone having any query?
Hello, madam. It was a nice presentation. Madam, there is one top point, security considerations.
Okay.
So also there is one group of practicals in CNL which is based on security aspect.
Yes, sir.
So what all should we cover all the security aspects? Like I'll just explain. Like in practical, there are
Actually,
uh,
in practical also included in afternoon session there is a having a hands-on on that practical assignment. You should attempt that one. Okay.
yeah, I'm going to attend. But in the theory, should you explain this HTTPS, SSL, and
Hmm.
SMIME, IPsec? Should we cover all these things in the security as considerations?
No, actually our uh, subject name is a computer networks.
Ah,
Okay.
right.
We just start from the bottom level, right? Covering
Yes.
the whatever the layers, and
Yes.
whenever we studying the networks now, we
Hmm.
just included in a last 5 unit little bit security related, right? So we required the next one subject for regarding cryptography or security, right?
Ah. No, so see, because in the practical, no, there are four practicals based on security. So in theory part, in under security consideration, what aspects should we cover? Like SSL, IPsec, SMIME, all those things. Should we cover this or not?
Give the introductory part in that actually. So
All for all the things, SSL, SMIME, and IPsec.
yes, sir.
Okay.
Any question for me? Any other one? Okay. Thank you, ma'am. Thank you, Pallavi, ma'am.
Thank
Thank you
you
so
once.
much. We will now turn to our next session, which is for unit number 3 and unit number 4. I'm truly joyful to introduce Dr. Ranjana Prakash Dahake, an accomplished academician and researcher in the field of computer engineering. Dr. Dahake completed her bachelor degree in computer engineering from Government College of Engineering, Amravati, followed by ME in Computer Science and Engineering from Government College of Engineering, Sri Sambhajinagar. She earned her PhD in Computer Engineering from Khushba Knowledge City, affiliated with Savitribai Phule Pune University in 2022. Demonstrating her commitment to holistic education, she has also completed a bachelor degree in Values and Spiritual Education from YCMOU. With nearly 2 decades of experience, Dr. Dahake has served as an expert speaker in numerous faculty orientation programs covering subjects such as computer networks and security, cloud computing, multimedia technology, usability engineering, latex, research paper writing, presentation skills, and soft skill development. Her passion for quality education and faculty development has earned her recognition across various academic platforms. Today, she will guide us through unit number 3 and unit number 4 for computer network syllabus. May I request Dr. Ranjana Prakash Dahake to kindly take over the session.
Thank you
Madam,
so much,
please
ma'am.
begin. Thank you.
Thank you, ma'am. Am I audible?
Yeah. Yes, ma'am, you are audible.
Thank you, ma'am, for the nice introduction. Let me share the presentation. Is it visible, ma'am?
Yes, ma'am, it's visible. Yes, it's visible.
So, good afternoon, dear all. Am I audible? Hello?
Audible, ma'am. Audible.
Yes, ma'am, you
Okay.
are audible.
Okay. Uh, is there any disturbance of other audio or the other noises?
Not yet.
Okay, fine. Okay. So thank you, BOS Pune, and the organizer, Keystone School of Engineering, uh, for giving me opportunity for presenting the content of unit number 3 and unit number 4 of computer network, which is in third year syllabus of 2024 patterns. So I'll try my best to give the input related to the examination. I just assume that the same subjects is there. The content of the previous syllabus in 2019 pattern has not changed much more. Some of the part is changed only. So many of all of us have just conducted this subject. So not much changes are there. Just I want to just clarify this. So wherever there is a change or wherever there is some explanation is needed in that part, I'll just go on explaining. Otherwise, the structure of different points which is to be explained in class or that I'm going to explain. So otherwise, the detailed explanation of the concept need not to explain to all of us, because everyone is knowing the content and all. The detailing we can do in the classroom, but the main thing is the different structure of the different points which is to be explained. So let us start. This is the agenda of the particular session. We You might have seen the same content like course introduction, syllabus, course objective, outcome. So we will brief it regarding the unit number 4 only. Then we will have some guidelines for the different two units, unit number 3 and 4. So, as you know that this is the new syllabus, and the credit system is also changed. That is 3 and 70 marks for the end and 30 marks for the CCE. Thereafter, the prerequisites are given over here, uh, like computer organization, or the, we can say, digital electronics and designs, discrete structure, mathematics. So you can see over here, these are the content of unit number 3. So these contents are for the network layer. So if we planned these content for teaching in different sections for the classroom teaching, so it will be helpful to us. So I'll try my best here to just segregate these different contents in different subparts. Like we can say that initially service and design are there. Thereafter, the routing algorithms, there are some protocols. So different subsections or subparts we can consider, and according to that, we can plan our classroom teaching. So these are the course objectives you might have seen before. The objective number 3 and the 4 are related to the unit number 3, and 4 is related to the unit number 4. As you can see, unit number 3 is network layer. So different functionality of the network layer are mentioned over here, like routing, like error control, congestion control, quality services, etc. And the 4, it is about the transport layer. Then unit number this 3 have some course outcome. After completing this course, the outcomes, the student must be able to know what are the different services provided by network layer. If it is unit number 3, then what are the different routing algorithms, and when and where it is to be used. Thereafter, if it is unit number 4, then the student must be able to compare different transport layer protocols, different services provided by transport layer protocol. So significantly, transport control protocol, or the user datagram protocol, or the SCTP or the RTP plays very important role in transport layer functionality. If you see the textbooks in the given in the syllabus, so the particular textbook for the unit number 3 and 4 is the first one, that is by Andrew Tannenbaum. So computer networks, this particular textbook gives you all the detailing of unit number 3 and 4. The partial or the some of the content are also you will find in the second textbook, that is the book by William Stalling, Data, Computer and Communication, 10th edition. These are the some reference book. Some detailed concept or some different concept you will find in the reference book. If you want, you can refer it. Some of the ebooks like this I got, and this is a good e-material that for the unit number 3 and also for the 4. This you can refer for the content preparation. Then whenever we go in a classroom for any of the content, we can think about that for a particular concept, for a particular topic. Am I trying to explain or trying to follow this particular skeleton? So what is the concept? Is there any history for the concept, or how we can define the concept, and exactly how the concept work? Is there any diagrammatical representation? Is there any mathematical representation, or is there any algorithmic base, or what real life example I can give for that particular concept, or where it can be used, its usability or the application, and is there any advantage, or what are the limitations, so that the new concept is formed. If we plan every of the point or the topic in a syllabus according to this structure, then it will become very easy to us to conduct the class and to memorize for the student also. So this particular skeleton I try to inculcate in all the presentation of unit number 3 and unit number 4. So you can see over here, the first topic of the unit number 3 is the different services and the design issues of the network layer. So the services of the network layer, the first one is the just forming the connection. So there are two types of topics are given in a syllabus, like connection oriented services and the connection less services. You all know that the connection oriented services forms the setups or the data transfer frames phase is there, termination phase is there. So we can go on explaining it in the form of concept, in the form of diagram, or we can also discuss about the benefits and the limitations of it. So basically it's a TCP protocol can be used for the connection oriented services, and it is reliable, but it has the overhead, that is it is slower, because it takes the time in setup phase and the exit phase or the tear down phase. Whereas the second topic given in a unit number 3 is that is connectionless services. So these you can see the difference over here. The same skeleton is to be formed, like it's working at no connection is formed. Its benefit that it's faster one, and the delay can be explained like just showing like this diagram. Even this particular in connection oriented communication, we can say the datagram, or we can say circuit switching. So all these the switching techniques are also very important role. They can be included in the explanation. So whenever these two different topics are given, so generally in examination, the differentiations are mostly asked. So the differentiation can be formed, or that can be studied by the students, or it can be discussed using different points, like how the connection is formed, what time is taken, whether it is reliable, whether any conjunction is carried over there, what is the mode of transfer, whether it is suitable for particular applications, whether retransmission is possible, how the packet travel, what is the delay. So all these are the parameters. We can give this parameter to the students and we can take answer from them. This is some exemplary I have listed over here. This type of differentiation can be formed. So the next topic in the unit number 3, you can see that is the quality of services. So basically in unit number 3 and in unit number 4 also the same topic is given. You might, if you have referred the syllabus, or you will come to know that the same topic is given. But there is a difference. The quality of services, which is, we can say, to be achieved at the network layer, that is different, and the quality of the services that is to be achieved at the transport layer, that is different. So the technique are also different. So here the quality of services that can be discussed, that by using some, we can say this different points, like what is the need of quality of services. So there is the, we do not want delay, we do not want jitter, we do not want packet loss. So this is a need. So what techniques are then there? So this congestion control, or the traffic prioritization, or the traffic management. So that can be, or the resource management, like routers, number of routers can be more, number of switches can be more, alternative path can be there. So all that can be the different techniques which can be discussed under this. Then why there is a QoS, where it is required. When there is an answer to be given for the where, then the application comes. So these are the general application where we want the best quality. Like when in the video conferencing, we do not want break. Like online gaming, like live streaming. So we can take answer from the students that where the quality of services you need. So this application automatically comes from them. Then you can see that these are the different points are listed in a syllabus, but these points are the under network layer services like error control, flow control, store and forward switching. All these are the services of the network layer. And what to be discussed over here, like we can say what is the need of this particular services, like in the error control, these different techniques are given here. These techniques are studied already in unit number 2. Need not to be tech in detail, but students must know these techniques, and the revision for this technique can be there so that they can understand that these techniques are used for this particularly service. Then also flow control, always with the different techniques like stop and wait, sliding window and all. Another different techniques are also there, selective repeat request and all. So the next one is stored and forward. So in the stored and forward, different switching techniques are also discussed, like packet switching, message switching, and all. And where these are used, like packet switching is internet, or circuit switching is in particularly telephone networks and all. So this can be discussed under the services. Now, the another concept is given in unit number 3, that is reliability. So, where the reliability is required, what is the importance of reliability? That must be made clear to the students, and then the techniques of these reliability can be discussed. So, for the reliability, we can take acknowledgement. For the reliability, we can take sequence number. For the reliability, the time out and timing. So all these time session can be we can say consider that is important. If the packet is not reached, then retransmission is possible. For that, error control, flow control technique also plays important. So all these to be discussed under the reliability. Reliability is not a single particular point to be discussed. So to achieve the reliability, the different techniques, combined techniques can be there in the discussion. Then the next topic, that is independent topic, is given, that is inter-networking challenges. So for that purpose, the what are the different networking concept. So that student must know before. So for that, afterwards, what is inter networking and what challenges are there, like we can say addressing techniques student must know. Then routing protocol, what is routing must know. Then protocol compatibility must know. If the one protocol is not compatible to another, then there is a challenge in inter networking. Then security issues can be there, scalability issues can be there. All these are the challenges. Now with the challenges, solutions can be also discussed. If one protocol is not suitable, then what is the another protocol, why that is suitable. So this particular when, why, how, all these questions to be asked for the each of the topic, and then the different concept can be discussed over here. So may these topics can be after this particular concept, like routing is afterward this. So you can change the sequence while explaining explanation in your class while discussing the unit number 3. Maybe addressing can be discussed before. Maybe protocol can be discussed before. Afterward, you can discuss the challenges before, because before discussion, the challenges cannot be discussed. Solutions cannot be there. Afterward, there are the different routing algorithms are there in a syllabus. Like the problem of flooding is also discussed over here there. And flooding, all flooding means sending the packet from by all the means, by all the path. But there is a problem that if you send the packet from all the path, that path automatically get congested. So this broadcasting in all the routes is not particularly all time it is used. Somewhere wherever it is necessary, it is okay. So and that's why different routing algorithms are there. So basically, shortest path we all time try to find out, and for that, different algorithms are there. So here in the routing algorithms, different routing techniques are initially discussed. We can say that distance vector routing is there, link status routing is there. So the static routing or dynamic routing, this is a base. So it comes under the dynamic routing. As per the requirement, the route is changed. So distance vector routing can be discussed, its working can be discussed, according to the discuss distance direction, the distance can be we can say calculated, which is the algorithm, where it is used, and what is that limitation, so that the next technique of the routing is there. Like next one is the link state routing. So what is the difference between link state routing and the distance vector routing? This is also asked in the examination. So here that difference can be, we can say, discussed, which algorithm is used in the link state routing, and the link state is we can say calculated, which link is on, which link is goes off. So that dynamic calculation is there of the route, that can be discussed, in which particular network it is used, which particular protocol is implemented for distance vector routing and for the link state routing. So that can be also discussed, that can be the point of differentiation. Now, the next topic in the unit number 3 is again for the particularly IP protocol. So IP protocol is very well-known protocol. All the students knows because we all use the internet and all, and by using IP addresses, we know this. So basically, while discussing IP protocol, where is the IP4 lags, so that IP6 is there in the picture. So because in the examination there is again chance to ask IP4 difference and the IP6 difference or the comparison. So we can say that as the address space get enhanced, more address space is there by using IP6 rather than IP4. But then how that is compatible, and that again to be a question, and then that is to be discussed in short. So basically, while discussing IP address, 2 points need to be considered. Student must be clear about what is network ID and what is the host ID. That is important over here. Again, there is a classful addressing for the IP4 addresses, but the classless address is to be also considered, because the next is topic is their classless addressing, that is CIDR addressing. So all you know, and this is what some brief is given over here. That is different classes are there based on uh, how many bytes are used for the network address and the host address, class A, class A to class E. So that difference must know, the examples of different classes must be considered, because there might be the numerical based on this particular topic, calculating the first address of a network, calculating the last address of a network, calculating the subnet mask. This is for the classful addressing, or this is for the classless addressing also. So it depends which type of questions are asked. So this is very important topic from the unit number 3. This is the heart of the unit, you can say. Then the next one is the CIDR. So we must take care about where the classful addressing lacks. That's why the new technique is their classless addressing. And what is the difference between this classful and the classless addressing? That is to be also discussed. Whether there are classes, no. Then what change is there? Whether that is flexible, that we can use any number of bits for the host or any number of bits for the network, that is to be discussed, and different examples is to be given, and some numeric is to be also solved. Thereafter, the next concept is their subnetting. So this is also very important topics. Why subnetting is there? What are the benefits of subnets? Because subnetting is implemented in every of the college network. So we can even show practically to them that subnet ID of our the particular college, host ID and the subnet ID, that can be segregated. Thereafter, what are the working of the subnettings and forming different subnets and all. So this is can be discussed with the diagrammatic representation also. Wherever possible, I put the diagrams over here, but that can be extended in the particular topic in the discussion of your classroom teaching. Thereafter, this IP4, IP6, this is very important topic. As I stated before, that this different must be covered in a classroom, because student must be able to know that how the different IP6 and IP4 addresses are used. What are the different addressing formats differences? Here in IP4 dot representation are used. Here it is in we can say hexadecimal numbers, and the colons are used. Then you can say that there is an IP4 protocol that can be separately asked in the examination. That's why we need to cover its data packet that can be considered the data and the header. Thereafter, the header separately need to consider, like it consists of the source address, destination address, and many more fields. So here one just it is provided for the representation. We will not go in detailing, but you can discuss it is a classroom. So every of the field must be clear to the students. It can be asked separately for 5 to 6 marks. Thereafter, the another protocol in the unit number 3, that is Internet Control Message Protocol. So this particular protocol can be used with the IP protocol. Where and how it is used? What is the purpose of this protocol? If this protocol is not there, what will happen? So this particular questionnaire is need to form and need to ask to the students. Thereafter, this protocol can be discussed with the different messages that is provided by this protocol, like echo, reply. Hello. Thereafter, is there any different disturbances, ma'am? Am I audible? Hello? Hello?
Yes, ma'am.
Yes.
Am I audible?
Yes,
Yes,
you
ma'am.
are.
You are audible.
Okay, fine. Some beep is generated, so just that's why I ask you. Thereafter, the next protocol, that is in the unit number 3, that is address resolution protocol. So it is used with the IP just for getting the IP to MAC. Its reverse protocol is also there. It is not included in a syllabus, but with the concern with this ARP, you can also discuss orally with the RARP, because it's a reverse forming the MAC to IP. So you can discuss with its header, and just exemplary working I have shown over here, how it provides the IP address and how it returns the physical MAC address. So the last topic of this unit, I think that is what the different routing protocols. So basically, two routing protocols are given in your syllabus, that is RIP protocol and OSPF protocol. So RIP protocol, that is implemented for the distance vector routing, and the OSPF is implemented for the link state routing, which routing algorithm we have discussed before. So these, while discussing these protocols, the working of this protocol, then different, we can say, how it performs routing, as well as its header format is also important to discuss. These are the some we can say detailed and long discussions, and are there very detailed protocols are there. These header formats are there, but considering the particularly 7 to 8 marks, or sometimes two questions are combined, we need to we can say take the detailing of this protocol also, just by considering the header format of these protocols. So while working, we can discuss its algorithm, its basic concepts and all, and also a header format of the two protocol, like RIP and OSPF. Now, this unit number 3 is ends with the case study, and that case study is particularly uh, IP6 protocols, how that can be used in ISPs. So, while studying this particularly case study, that particular student can perform that particularly uh, studying of or analyzing of different ISPs, different migration challenges, like how IP4 address can be migrated, or the we can say compatible to the IP6 network. What are the different techniques which is not included in the syllabus? So that is important. Whenever the larger address space is required, this IP6 is used. This is very clear while discussing the case studies. And based on that, whatever the detailing are there of IP6, which is to be adopted in the ISP, so that is to be discussed. Some points are listed over here, but they are not the limited one. Again, the second part of this case study of unit number 3 is OSP is used in what the enterprise network. So as we know that the OSP and the RIP, these are the two routing protocol. So this why OSP is there? What are the which particular network is to be used for this OSP? And the detailed methods, its scalability in the network, and some exemplary we can say networks is to be studied for the analysis purpose. So this is all about for the unit number 3 with the case studies. Now uh, shall we continue for the unit number 4, or we will take the questionnaire on unit number 3, and after that we will cover the unit number 4 detailing. Can I continue, ma'am?
Yes, ma'am. Please continue.
Okay, fine. So these are the content of unit number 4. As you can see that in the unit number 4, this is all about the transport layer protocol. So transport layer functionalities, transport layer services, as well as transport layer different protocols are listed over here. And let us see the detailing how we can cover. Now, in the transport layer protocol, the different functionalities or the services provided by the transport layer protocol, the first topic mentioned in the syllabus, that is process to process delivery. So basically, what is process to process delivery? What is the purpose of process to process delivery, and how it works, and which protocol are included? It is to be discussed. Like it is used for the communication between application running over on different devices. It is one process can talk to the another process through the IP address. One process can have the port numbers, and that particular is the process to process delivery. You can see over here the diagrammatic representation like this can be drawn, can be shown to the students. Where are the different nodes? Where are the different processes? What address to be given for the different processes? What is the address of a node, and how different processes can be we can say sending data to the another processes. What are the different addressing mechanism in this? So basically there is a multiplexing and demultiplexing mechanism over here. That particular concept is included in the same syllabus. This is in the further discussion, so we will see it. Now, another topic, subtopic, a single topic is given over in a syllabus, that is services. So, which services we can consider? The services of transport layer, like connection-oriented services, connection-less services. Reliable transfer is a major, we can say, majorly considered for the transport layer, because data is transferring, so it must be transferred reliably. So, reliable transfer is very, very important. So, this particular topics we have already discussed, and this is comes in a further discussion also. Now the key concept of the unit number 4 that is given over here, that is socket programming. The assignments or the practical assignments are also there for the socket programming. So before we can say explaining this particular concept, the student must be clear about what is the socket address, because the normal addressing and the socket addressing is different. Socket address is formed by using the port number and the IP address. As before in the concept, we have seen that there is the port address for the each of the process. So process on a server is going to talk to the process to the client, or process on a client is going to talk to the process on a server. So this is the communication between the two end. So endpoint communication is nothing but the socket programming. So for that socket programming, we need to form a connection. We need to just send the data, or we need to again close the connection. So which type of sockets are there? Stream sockets are there, raw sockets are there, in datagram sockets are there, different socket types are there. According to that, these connection formations and the closing is occurred. And for this particular concept, student must be very well about socket primitives. Socket, then accept, then listen, whichever are applicable for the TCP socket, whichever are applicable for the UDP socket. So socket primitives are very, very important over here. Thereafter, next topic in the syllabus is listed, that is elements of transport layer protocol. So basically, elements are nothing but the different functionalities that is carried out by the transport layer. You can see over here addressing, flow control, error control, multiplexing, congestion control, reliability. All these are the tasks performed by the network of this transport layer. So these are nothing but the elements. Thereafter, the addressing is to be discussed in detail over here in the transport layer for considering the socket, because at the transport layer, the process communication takes place. So address is formed by using the port and the IP address. The next and the important topic over here, the connection establishment. The connection establishment takes place for the connection oriented services. So while connection establishment, how the connection is formed, simple connection establishment is explained over here for the TCP protocol. That is three-way connection establishment is shown over here. It is an exemplary diagrammatic representation showing the client communication and the server communication. You can see over here. The sync message is there. It is called as three-way communications. That is, connection is established. Thereafter, the data exchange can be there. Likewise, communication established, there is a connection termination or the connection release also after the data transfer. So that is the four-way termination, you can say. First, the finish message is sent, then acknowledgement, then connection termination, then again re-acknowledgement. So likewise, a basic concept can be discussed with its working with the diagrammatic representation by using the different examples also. The next topic in the unit number 4, that is the flow control and the buffering. This is also a function of the transport layer. So that particularly flow control, as we know that it is studied in unit number 2, that is for the data link layer, but same flow control is also there for the transport layer. So it manages the speed of data transfer. So that particularly to be discussed in this particular part also, and the buffering also there. So basically, buffering can also be used for the QoS also, so that the some of the particular data segment that is not received, that is for the while it is to be buffer, and that is sent. The multiplexing part that I just stated before this, and that is used in the addressing of the transport layer. So multiplexing, when there is multiplexing, again the another concept demultiplexing comes over here. So as you can see over here, in the concept of multiplexing, different processes, different we can say processes forms one address, multiplex one, combined in one IP. IP is given, it is demultiplex for the different process IP, because port number is different for the different processes. IP is same for the different IPs form, and that is same for from one sender, and it is again same at the receiver, but the process uh, port number is different. So that concept of multiplexing can be explained again with the help of diagram, how it is carried out for the transport layer. Then very important concept in the unit number 4, that is congestion control. So the congestion control technique, why the congestion occurs, with the reason it can be discussed, as the bandwidth can be limited and there is a high traffic, like road examples of, can also be taken for the real time we can say systems. Thereafter, different techniques, independently these techniques need to cover, because there may be some questionnaires on leaky bucket and the token bucket we can say techniques. So how leaky bucket works, how token bucket works. So these are the different congestion control techniques used in the transport layer. The different diagrammatic representation are there, and different we can say conceptual explanation are also there. Each of it has its own benefit and the limitation. just for the sake of time and the total number of that PPTs, I just have not considered over here. But for that congestion control, this need to be discussed. Again, I explained before, this topic is also there in the network layer, again in the transport layer. So this transaction control and the you can say network layer and the transport layer, they both are at the different levels. Here the congestion control for the management of the routers, the packet queue and all, and here transaction control is for the because independent, we can say that systems. So for that particularly, TCP slow start, congestion avoidance, fast retransmission, all these are the techniques. So these all the techniques are discussed in the given textbooks. So with the examples, with the diagrammatic representations, all the techniques are very nicely they are discussed over there. Now, the next protocol in the transport layer, that is stream control transmission protocol. As there are the TCP and UDP, we all know this. Why this SCTP is there? What is the difference between the SCTP and TCP protocol? That must be cleared. Must be cleared firstly. Uh, so as there are the multiple streams that can be utilized with the SCTP protocol, that's why SCTP is in a picture. Now the concept is discussed. It's we can say different features or the different functionalities can be stated. It can be clarified with the different diagrammatic representation. The next topic is in the unit number 4 is RTP. This is very interesting topics. We can explain this topic with the multimedia examples to the students, like whether the TCP is used over there or the RTP is used. Why TCP is not used? Why RTP is used? What is the drawback of TCP if we use, or is the advantage of RTP used over here? Like in an application like video conference, multimedia application, live streaming, for the transmission purpose, the RTP is used. It is nothing but we can say the upper layer of TCP, synchronization between the multimedia data. So here the head
Ranjana ma'am, you are not audible.
or website, or we can say UDP is used in the gaming or VoIP. Like connection oriented, why connection less services. There are also this discussion can be there. There are its header format also very important, and that must be discussed in the classroom. Both of the protocol header format, it is given over here. Now, QoS is also to be we can say discussed in the unit number 3, that is a network layer and in transport layer also. QoS is very important part because at every layer we need the can say quality. There should not be a break between the communication. There should not be stop between the we can say video or the audio. So at every layer, that particular the network layer or the transport layer, the QoS is to be achieved. That is different. It is mentioned in the syllabus. Then the next topic, that is a differentiated service. So why differentiated services are there? What is the criteria to choose the differentiated service when we choose TCP, when we choose UDP? So what is that particularly priority to choose TCP? What is the priority to choose UDP? So at different levels, the network service, whenever that particular quality-based services are used, the differentiated services can be used. That is depend upon the protocol. So that must be clear. It can be explained with some we can say the examples for the TCP application and for the UDP application. Then there is also given a separate topic, that is TCP and the UDP for the wireless network. So we can discuss that how TCP is suited for the wireless network, how UDP is suited for the wireless network. network, and what are the challenge for the TCP, and what are the challenges or what are the advantage for the UDP. Generally, the that particularly UDP provides us a fast communication for the connection or less services. But sometimes some frames, some packets may lost, so there is not a reliability. But that can be for the in the TCP it won't occur. So these are the different content of unit number, particularly 4, and the case study that is given in particularly unit number 4 for the transportation layer, that is for the TCP congestion control, how it is to be studied in 4G or 5G network. So for achieving this particular, the first part of this case study, it is very important how congestion is occurred in TCP. Then it is for the 5G network, it is for the 4G network, how it is differentiated. Then RTP video conferencing. So this, as RTP protocol is there, so here some particular example of video conferencing can be considered, and in that case with the RTP, RSTP protocol is also there. RSTP protocol is just for the we can say play, for forward, and all these controls. So RTP with the RSTP can also be explained with this type of case studies. So it is not to be explained actually. We must tell to the students that what they have to do, which points they have to study and analyze, and for that purpose, what particular short report or the we can say answers they can give in this particular case study. So this is all about the unit number 4. So here I stop from my side for the unit number 3 and the unit number 4 inputs. Thanks for your patient listening. Actually, it is heavy for the in online mode, but I hope I reach to you. And if there are any queries or doubts, always welcome. Thank you, ma'am. You can ask.
Yes. Anyone can ask the question on based on unit number 3 and 4. If anyone is having, please ask. You can chat also. Any questions from participants? Faculty members, you can ask question based on unit number 3 and 4. Yes, content and recording will be shared after the session completion. Okay. Now I would like to request all participants to switch on the camera. We will take in the screenshot. Prior to that, I would like to conclude the morning theoretical session, and now we will be having a break for 1 hour from 1 p.m. to 2 p.m. and we will be gathering again online at 2 p.m. I kindly request all participants to switch on your camera. Um, hmm. Now I would like to thank you, ma'am. Thank you, Ranjana, ma'am. Thank you so much. Your systematic explanation and your teaching methodologies, application-oriented technology successfully completed the theoretical session about unit number 3 and 4. We sincerely appreciate your valuable guidance. Thank you, ma'am. Thank you so much.
Thank you, ma'am.
We will gather again at 2 p.m. You can have lunch. Thank you so much.